Hello, we are back into the lesson. This is about now the application of what we've been doing in the algebraic fractions. We have had several skills, we know how to multiply, to add, subtract, and even solving the equations. So it's like now, how do you apply this one now into the real life situation? Right, so please, I first of all urge you and ask you, and I plead that let us always remember to follow the link down here, study all the videos, so that what we're doing should be meaningful and should be able to follow. So this is the end point of the topic, where we just need to see application of the operations we have been doing to say in real life situation, can we manage to have some problems where they need type of knowledge? So we're saying yes. Right, so here with me is an example of the word problem that signals the real life situation, where here and there you find that some principles that we'll be discussing can be able to apply. Right, here now we have for the story a little bit of somebody who is on a journey. Right, it can be yourself. We walk, maybe a car can move, things like that. So a real life situation, a man, woman who is driving. So we're told this here, the woman who drove a distance of 100 kilometers. On a return journey, she drove 10 kilometers per hour faster and took 30 minutes less. So the question is, what was her speed on the outward journey? Look at that. A woman drove a distance of 100 kilometers. On the return journey, she drove 100 kilometers faster and took 30 minutes less. What was her speed on the outward journey, which was going out, not coming back? Right. So this is a real life situation. We move, objects can move. So knowledge to use, to apply, the knowledge that you can use in order to come up with the value of what we want. Like in this case, we are looking for the quantity, which is the speed. How do we find the speed in this case? So what we are saying is that some knowledge of what we have just discussed in the topic can be able to help us to find the solution to such type of problems in life. Right. So what is just needed is just a matter of you to understand what is it contained in the question. And then as the students have to brain up and connect up the ideas and knowledge and come up with the processes that can take you to the solution as such. Right. So now, without talking too much, I'll just help you to think, because I cannot leave it to you because it can take time and we are not even together here. Right. So I'll just give you one area of thought to say how can we handle this one out. Right. One way is just by considering out that, say, each time we talk of problems about journeys, you have to remember that every time something is in motion, there are three quantities which are happening automatically. If these quantities are not there, it means the issue about motion does not exist. An issue about the journey or this woman will not even drive the car. What are these quantities? You bear with me, when something is moving, you expect distance to be covered. So every time we'd like to consider a problem about the journey, consider issue about the distances. Secondly, speed must be there. How can something displace going somewhere else without a particular speed? So speed is just automatic. And what do you expect again? Time must also be what? Taken. I move from here up to a certain distance. I may take maybe a minute or some seconds aside. So the same here, you need at least to consider three quantities: distance, speed, and time. So this one can also be worked by analyzing principles attached to time, speed, and what? Distance. So it's like now, how do we involve distance, speed, and time, the three quantities, into this problem to such extent that we can have the value of what? The speed on the outward journey. So look at this. The first thing that you do is to at least summarize the equation aside. And then once of summarizing, you'll be able to see the direction. And more importantly, if you'd like to find the quantity which is not known, usually the students always bear in mind, usually in word problems, how to solve those ones. You always have to consider issue about what? Equations. Solutions are mostly found in word problems by coming up with a certain equation. So what we'll be doing, whatever we do here, though, we're going to involve those three quantities in regard. We have to see ourselves coming up with the equation that is really appropriate and that can take us into the what? Value of the variable. In this case, is the speed on the outward journey. So here is what I'll do in the summary. Right? I've talked of the distance must be taken when the journey is emphasized. So right about the distance, in this case we talk of the woman. How much distance does she cover? I also expect the speed to be taken. So I need also to involve it's about speed. What is the speed was taken here? But it may not be mentioned, but still more. There's something about speed. Lastly, we have to expect about the time. How much time was taken when she was moving. Right. So if we can at least summarize the equation based on distance, speed, and time, this is what we are going to have. Look at this. If you talk of a distance, the distance in this case is covered into two folds. One for the outward journey. Second, it is for the return journey. If you can read the question, it's talking of the outward and also the what? The return. It means she went out and she came back. So whatever I write about the distance, I have to consider two situations. One, let me remove first of all the weight mathematics in order to have more space. I will talk of the outward journey and also the what? Return journey. Right. So as much as we talk of issues about the journey, somebody went out and come back, we expect the distance covered out is 100 kilometers. By this, a woman drove 100 kilometers. And then if you talk of issue about return, we don't expect a different distance covered, but we also consider the same what? 100 what? Kilometers. So here in this case, it means we'll be able to consider that the woman covered 100 kilometers when she was going out and also covered the same distance 100 kilometers when coming back. Second, let's talk of the speed. What was the speed did she use when going out and then coming back? So what we have here, we'll be able to see that the question does not specifically tell us what speed she used when going out. The same when coming back, that's the return. So if a quantity is not known, in such case, we are using a certain variable to represent that quantity of our interest. So like here, speed is not defined. So we say, let the speed she used when going out be x kilometers per hour, right? So when coming back, it was also supposed to be what? X kilometers per hour. But now we are told that she drove 10 kilometers per hour faster. It doesn't mean she drove 10 kilometers when coming back. But faster, it means the speed that she used when going out, she added, she increased it by 10 kilometers. So it means when she was coming back, it was like x plus what? 10. That's it. Kilometers per hour. So the speed when coming back, it is x plus 10 kilometers per hour. That's the speed on the return. So please take it. Distance 100 out, distance 100 returning. And also speed out is x kilometers per hour. And then coming back, it means she drove faster. That is x plus 10 kilometers. Now, that's 10 per hour plus 10 kilometers per hour. Right, here you can set some brackets aside. Now for the time, it's expected. Though it cannot be indicated, but still have to work out in time. Because these quantities, they work hand in hand. So now here, we are not told about the time she took when going out, and also the time she took when coming back. But we're just told that, say, when coming back, mark that the speed was increased. She saved 30 minutes. So it's more like there's a difference between the time going out and the time she took when coming back. The two times differ by 30 minutes. So what are these times? So since it is not stipulated, we can still apply some operations. How we can find those times? We know for sure that once we know the value of the distance and speed, we can be able to find the value of time by just dividing distance by speed. So it means here time will be 100 divided by x. This is what? Hours. You see that? Distance over time. The same way, when she was returning, we assume that the expression representing the, that's the talk of the time taken, should be distance, which is 100 divided by what? X plus 10. So this is the expression representing the time when coming back. So that's the way it is. So now you can see that the question here has been summarized into 3 stages. One, we're talking about the distance, that's it, of the return and out, and also the speed out and return, and then time out and return. Right. But now, our question is, how much was the speed on the outward journey? So by this, you can be able to analyze that, say, what the question is trying us to ask is just like the value of x, because it is the x that is representing the speed for the outward journey. So here, we need just to find a value that is representing x. So as I said, you can't just find the value of the variable as such, but what you need to do is formulate an equation that will be able to solve for x. Right. So it's just like now, how do you come up with that equation? Right. By this, what you have here, you found that the equation is always centered within this statement here and took 30 minutes less. Which means, as you can compare here, the speed when going out was higher, x plus 10. Here it was just x, which now this is more. It means that the time taken when going out was more than time when coming back. So as such, we expect this time to be greater than this one. So which means the two times, they differ by what? 30 minutes, which is just like half an hour. So here it means that, say, we have 100 for the time taken when going out, subtracting the 100 over x plus 10 when coming in. That give us what? 1 over 2. Okay, 30 minutes in that case. So this is the kind of equation coming from the time going out, time coming in. The two differs by 30 minutes, which is half an hour. So once we have this one, then the rest of the story is historical. We have the same situation that we have previously in the video. We can just find the value of x by solving that equation as such. So what do we do? Let us formulate one equation on this side here. We'll have here a common denominator, x open bracket, x plus 10, like that. On the right hand side, we still have what? A half. So we say x getting into this one. What do we have? This will be the answer because x will cancel this. So it means this multiplied by 100. We'll have 100 open brackets x plus 10. And here we'll write minus like that. Then x plus 10 will get into x plus 10. The answer is x. So this x will multiply by 100. So to have negative 100 what? X as such. You see? So from there, what do you do? Just keep on solving as we have done in the previous video where we're solving the equations. Right. So what I have here, to increase up the space, allow me to remove this chart. Take it for granted that you have taken note of the equation that is here. Now, from here, just expand the expressions by moving the brackets. So in the numerator, we'll have 100x, then plus what? 1000, and then there we have got minus 100x, and this one should be over what? That's the x open bracket x plus what? That's a 10. On this side here, we still have what? A half as such. Right. We have like terms there on top. So it means this and this one like terms. So it means 100x and 100x will go. So it means you have got 1000 over top of x open bracket x plus 10. And this side here we have got what? A half as such. Right. So what do we do? Issue about cross multiplication now comes in. Remember what we have done in the previous video? That's it. So what do we have? This multiplied by this and this multiplied by that. So here the one multiplied by this will get the same, and this multiplied by this one will get, that's a 2, that's a 12,000 is equal to this multiplied by that one will go to x plus what? Plus a 10. That's what we have. Now, from there, where do we go? What we have now is just like now, we have to simplify this part here. We have got here now 2000, which is equal to x squared plus what? 10x. Right. So from what you can see there, you'll be able to observe that what we have there is just like what is the quadratic equation. You can see the equation have got a variable x which has got the highest powers 2. So which means when you're solving this one, you may see that there are no like terms. So you need to follow the procedures above the quadratic equation. So how do you go about it? So remember in the previous video where we were discussing about the algebraic expressions, we were even solving algebraic what? Sorry, talk of the quadratic what? Equations. So we go by those principles. So the first step to solve the quadratic equation is by expressing the equation to what? To 0. So what I have to do here, I have to make sure that terms from one side have to go off to the other side. So I'll decide to transfer the 2000 to the right hand side and have your x squared plus 10x. So this now here to be what? Negative. That is a 2000 like this. Right, that's what we have. So when I say this is as good as writing what? X squared plus 10x minus that is 2000. Right, which is equal to a 0 like this. So what are we going to do next? Procedures of the quadratic equations remains intact. So now, once the equation has been equated to 0, what is next? We have to factorize this part here. The expression. This is an expression. The entire square with the equal sign is the equation. So we're going to target this part here and factorize it out. Right. So when we factorize this one, we'll be able to realize that the factors for this one are x. That's to get a 10, we can consider factors of negative 2000. That when you add, they have to give you positive 10. You may have factors of negative 2000. First of all, that can give you a positive 10 when you add. You realize here, I think we may have what? 50 multiplied by 40. Let's see, 0, 0. 0 here, I've got what? 20. So you have got 2000 here. So if one of the two factors here, between 50 and 40, for us to add to get a 10, it means 50 should have what? A positive, while 40 should have what? A negative. Such that when I multiply negative 40 times 50 should give me negative 2000. Yes. But when I add 50 and a 40 should give me what? Positive 10. So which means the factors want here for the negative 2000 are 50 and negative 40. So which means by those factors, it means if I'm to completely factorize this one, the factors of which should be x, that is minus 40 multiplied by x plus what? 50. And this should be what? A 0. I know we all know how to factorize this by grouping method. Right, now from here, what does the principles of the quadratic equation tell us to do? Mark that we have done the factorization and found the factors of this one like that. So here, it means we are going to split these two brackets into individual equations. So it will be like x minus 40 alone should be equated to 0. And again we say, oh, x plus 50 should also be equal to what? To 0. And from there, we'll be able to work out for the value of x. And x from this, you just arrange like terms, negative 40 and the 0 are like terms. So this comes to that one, and you get what? 40 aside. Or x here to be negative what? 50. So that's what we have there. So remember, in the previous summary, when we started solving this one, we let x being the speed on the what? Outward journey. Look at this one. The question is about this. Right. So what was the speed on the outward journey? So in our case, we presented x as the speed on the outward journey. So here we found x as equal to 40 or x is equal to negative 50. So now, in life situation, a method of solving quadratic equation just gives you the values. X is this, x is that. Now, it's now come to you now to decide, because you cannot have two values of a particular quantity. That's not possible. So you'll be able now to analyze. I've got the value of x as 40 and negative 50. Which one should I go for? Right. So now you analyze things. Say, if now I try to consider about this question, because it's a real life situation, we are asking about the speeds. So you'll be able to at least to consider in your head to say, can speed be negative or say positive? Like say sometimes you solve the equation and x maybe is representing age. You have found two values. One is negative, another is positive. So what you do in that circumstances, if you realize that the quantity you're working for cannot be in negative, then you have to ignore that negative value and then try to consider the one, the positive one. So in this case, since we know that the speed cannot be negative, then right, ignore that's a negative 50 because we don't expect the value of this quantity to be negative. So we consider that x as equal to 40. Right. So by that, then we conclude that say therefore speed on the outward journey is what? 40 kilometers per hour. Right. So that's it, my dear students. You can see how we've done that, and that's worked very well. We've brought some issues about addition of the fraction somewhere on the stage, you can see, and somewhere we've also done issues about the what? Solving of the equation until we have arrived at the what? Value of the variable, which is the speed. By this, I end my case. And this marks the end of the entire topic. So what I'll just need you to do, I'll not give an exercise here because we have already had a lot of work, and I will just advise you to just revise what we have done until you master the skills as such. Thank you very much, but remember not to forget to revise the lessons in this topic by going back to the previous videos. The link is down here. Thank you very much.